Hello everyone, my name is Bhushan Chitri, and for my master's project I worked under Dr. Jane Hayes on automated requirement traceability, the study of human experts. Now let's get started with the talk. This is just a little bit outline that on how I'll be presenting my talk today. So I'll start with the introduction, then I'll get into background, motivation, then I'll talk about the Retro.net, the tool I worked on, and the improvements I made on it. Then, since this study required human subjects, so we before we could start the study, we had to have approval from IRB on campus. So I'll talk about that process. Then I'll get into validation. That would include the data set we use, the experiment process, the analysis, the data collection, the results. Then I'll talk about a little bit about relative work, and then I'll finish the talk with the conclusions and future plans that we have with this project and a little bit demo of the experiment. So as we already know, in every software development process, we have requirements, which we are calling it high-level document. And then once you have collected all the requirements, you go get into the experimental design. So that would be UML diagram, class diagrams, and then implementation, which is the code, source code, and then we are calling this group low-level documents. So it's extremely critical in safety critical software such as in medical software, so the NASA space shuttle or nuclear plant softwares where they want to make sure that all the high-level requirements are implemented at the low-level documents. And so how do we make sure that? So we use the requirements tracing. So we have these automated methods that generate this candidate traceability matrix, which is the collection of these possible links between these high-level document and low-level document, that as you can see in the diagram, using the information retrieval methods. So some might say, well, our job is done here, but in reality, the automated methods, the tools are based on the vector space model or vanilla space model or deep learning techniques, and but they are not 100% accurate. Often they generate unrelated items, which is false links. So how do we fix that problem? So our one solution is that when we get these candidate traceability matrices out of these auto-generated tools, we have human expert do the validation and verification. So our experiment gonna is based on that. So we have this Retro.net tool that was developed at University of Kentucky by former students, where it also generates this candidate traceability matrix between these two artifacts. So I took modify the original version to fit our experiment study, and I'm calling that control version. And the other version that I added the additional functionality to make the vetting process can assist the user in making decision. I'm calling that experimental version, version 4. And then next part of my project that I conducted the human study experiment where I recruited human subjects or experts and compared they did the vetting process and then compared the results that I received from version 3 and version 4. So a little bit background that I already mentioned, that requirement tracing, it's just the ability to describe and follow the life cycle of the requirements in both high level forward and backward. So you can go trace from the requirements to high to low, or requirements to test cases, or code to test cases, or code to requirements. So also another background that I wanted to mention here is that similar study was done in 2010 in David Curlback, Alex Richter, and Dr. Jane Hayes paper, where they also used the old version of retro.net, and they did their experiment a little bit different, where they generated these candidate traceability matrices with a certain level or percentage of recall and precision, and then they gave those to the human analyst and see if they improved or decreased the precision recall into the final traceability matrix. So a little bit of our motivation. So paper 2 and 3, which is listed here as advancing candidate link generation for requirement tracing, and then the paper by V. Kong and Jane Hayes, where basically they claim that first intuition is always the more accurate than if the user goes back and change the link decision, and then will most likely make mistakes. And then second one was that if analysts who are spending more than average time on particular requirement than others, then they would most likely make mistakes. Then these are the functionalities that I added into the experimental retro.net, where I added the user login form, where it is lets user log in from their user ID and password, where and it eliminates the initial project setup process, where you have to give the path to each of the high level, low level document, and then stop or remove file. In this, it eliminates that process, and they can go straight to their experiment. And also at the end, we could identify the difference between the different users results, because it would identify the user ID. Then exporting the traceability matrix in CSV format. So right now, the previous tool, you could view the XML as it's the collection of link decisions. So in that, I added the functionality where at any time you can just download them as CSV format, and then calculation monitor prime time function, where this function was a little bit tricky to add, where if the user starts with the high level requirement and then he does the link decision on the lower level document, and then once he's finished with at least three of the first three of, so for example, R1, R2, R3 requirements, and then suppose now he's at the R4 requirement and he passes the 10% more time than the previous three requirements, then it will prompt the user saying that, our study shows that if you're taking longer time than your previous requirements, then you would most likely make mistakes. And then the project timer, where we also ask user to record their times at the end of the study. So this added function where they can just start the clock when they finish the start the clock when they start the experiment, and they can stop it and keep the record of it. And if the user wants to finish the study in one setting, then the time is automatically added in hour, minute, second format at the final RTM. And then the revisiting link prompting, where if the user, for suppose at one lower level, user has changed the link decision for link or not from default, and then for some reason he goes back to change that decision, then it would prompt the user saying, hey, our study shows that if you try to change the previous link decision, you're most likely going to make mistakes. And then also since this retro.net setup install package, since this was going to be distributed with a lot of the students, we wanted to make sure that it's easy to install all the package and the project opens up instantly. There is no initial steps that they have to do. So I created this installer package where they can just on any Windows machine right now with the .NET framework, it installs the package. Then the last one is just some performance improvements where this tool was developed in 2010, so there are a lot of the libraries and updates were kind of outdated. So I brought them back to up to date on 2015. So as already mentioned, code is implemented in C Sharp in Visual Studio 2015, and just to give the overview, that login form, it was two components where it's designing the login form, which is similar for the control and the experimental version, and then actual login form functionality where and the 20 lines of user check, which is also hosted on my multi-lab server, which is keeping track of the username and passwords. Then exporting the RTM, which involves adding functionalities in several different components of the retro calculation, the prime time, and then these are just the other added functionalities where it just describes the lines of code it required to add that functionality. So Retro.NET implementation. So Retro.NET has this sub 9 sub projects. So in Visual Studio, you have like this main solution or main big project. So and then you have all these sub projects that you can. It's like a pluggable architecture. So if you want to add like some functionality instead of making changes within the software or tool, you can just create the separate architecture or functionality, and then you can just incorporate in the sub project folder. So basically you have 9 folder here. They have all the different functionalities. Some of them are do the algorithms data, some of them do the handle the user interface, some of them handle the experimental data collection backend, some of them are help, helpers for the installation package and different permissions. So this is the kind of like how the flow works in the retro.net, where you have these initial documents, like we have this high level document and low level document, and then I'll explain these each of the functions in on the later slides, but it basically flows from the similar in both of the documents, where it starts from the high level document, generate the document term list, name the terms, remove the stop words, count the term frequency, then calculate term frequency, so on, and then it all of that filter out data. The final list is collected in the high level document collection. Similar, it's collected in low level document, then it normalizes the documents, then it calculates the candidate links, and then it filter the candidate links, then it creates another candidate link collection, and then it goes to the feedback, and then it loops until you have all the data processed. So this is the how the initial document process happens. So you start with the general term list where, for example, this sentence here, click on the program icon on the desktop on desktop to start the application properly. So in this one, it based on the delimiters such as commas, periods, spaces, it separates the word and makes them as their individual terms. Then it stamps the terms. So, for example, if the word is clicking to make sure that they're matched accurately of different versions of the word. Next step is remove the repeated remove the stop word remove. So in this one, a lot of the English words are repeated just in both documents, so that doesn't mean they have linked there. So most common words such as a, the, on, all of these English words are provided to the tool, and then it just basically removes them, so we don't have any false links between the two artifacts. Then it just calculates the term frequency, where how many times the item or the word term has occurred, and then it gives the assigns the weight value to it to give like the importance. Then it normalizes the document, and then it filters unnecessary terms. So you can make these custom filters if you don't want certain words to be included. The actual algorithms are used in this tool are vector space model using the term frequency inverse document frequency. So it's in short TF-IDF weighting. So vector space model is originally developed at Cornell University in 1960s and early 1970s. So vector-based model works like information retrieval, where you are giving a certain query to the document collection. So in this case, vector-based model represents both of the query and the document as n-dimensional space vectors, and then it calculates the similarity between these two vectors. And then when it calculates the similarity by using the cosine functions for the two vectors. On the other hand, TF-IDF was implemented in the iTerm weight calculator function, where it's just going through the finding the maximum frequency item occur in this vector, and then calculating the weight of that using the formula is function frequency divided by maximum document frequency times the log of the total number of documents divided by log of number of documents term occur in. Then it just basically normalizes it and inverse document frequency of the double retrograde testing. Since we are um, students from different computers and different labs of Windows machines, were going to install this retro.net on, so we had to make sure that all the functionality is working same for all the machines. So I tested and installed at least 12 different Windows machines, some personal and some on the computer resource labs throughout the university campus. We ran several different test cases, such as how the system installation works. Experiment can start properly. You can log in and as all the error checking process. You can save the current progress of the experiment, different prompt messages, save or show the XML, timer recording, and several other functions. So pre-experiment process and human study IRB approval. Like I already mentioned, for any human study, you must need approval from Office of Research and Integrity on campus. So our study fall under the non-medical IRB protocol. So prior to starting the IRB proposal, I first had to be certified at human subject protection training, where it just basically goes over you're not going to hurt anybody's religion with your data analysis or hurt particular group of people or researchers. And so it's just basically general um, giving you idea about how to handle the data in the human subjects and how not to hurt them and keep the risk level minimum. Then we submitted our IRB in middle of early January, and then they have certain deadlines every 3 weeks that you can submit. But after that, they only review your proposal after that 2 weeks, and then they have like a committee who either approves it or sends you back with some queries. So in our case, we were sent back um, for like almost 3 revisions for the proposal and answered several of their questions. And then finally, in middle of February, end of February, we received the RB. Then now I'll talk about the actual experiment in validation, where I'll discuss the research question, our different variables, hypothesis, experimental design, traceability, and results. So we had these two main research question for this experiment, whether or not our experimental retro version performs better than the control retro version in terms of precision recall, and does the amount of time spent on the retro version improve the precision and or recall of the final RTM. So in our case, our independent variables were these two different retro.net versions, which is control and experimental. Our dependent variable were precision recall if to measure, lag, and time log, which is the time spent to perform the study. I'll discuss these measures in details on next slides. And our control variables were the actual answer set or golden standard for the change time and the actual retro.net tool. So precision is just percentage of number of correct links returned divided by number of returned links, number of total returned links, and recall is number of correct links returned divided by total number of only correct links, not all the returned links. And F measure is just basically their harmonic mean of recall and precision. And when we're saying F to measure, it's F measure when A is equal to 2 and it's more given priority onto the recall side. While on the other hand, lag is the measure of separation between the true and false links, and it was calculated using this formula. So our null hypothesis was that there won't be no improvement in precision recall in both tools. And our alternative hypothesis was that there will be improvement or decrement in both versions of the retro.net. So for this project, we used two data sets which were provided by research at Cal Poly University, and our training data set was Moonlander. It was very small. It only had 10 functional requirements and 5 system tests. Our experimental data set was called Chainstyle, which was a little bit larger. It had 32 requirements, which consisted of 18 functional and 14 non-functional, and 17 were system tests. So we chose this because it was written by the upper division software engineering student for Java code formatter software, and it has appropriate size for small tracing experiment study. So our human subject recruitment method was that we initially recruited 20 students in software engineering class at University of Kentucky, and then they signed informed consent and filled a pre-study survey as their form of agreement to participate in our study. For they were given 1% extra credit in their class assignment, and if the people didn't want to participate, then they had other options to gain the 1% extra credit. And then we held the demo session of the tool where They got familiar with using retro, and then after that they worked on their own using Moonlander dataset. Then I analyzed the results from the pre-study survey where it just talked about their background, what kind of classes they had, what kind of experimental uh, interesting background they had, or an industry experiment. So, so I analyzed them and I formed them into two groups, control and experimental, and I made sure that all the experienced participants were equally divided in control and experimental group. And then I assign all the participants their user ID and password where they used to access the experiment. After 1 week, they were given instruction to how to use the tool, download the experiment, and then they had approximately 2 weeks to finish the task, send back the results. So this is basically how the experiment process works. You give them the initial data set, retro.net spits out the candidate traceability matrix, and then our human analysts, in our case students, perform the weighting task on those matrices, and then they come to by changing the link or not link, satisfied with the high level requirement or not, and then they come to the final RTM, and then they send us back those results. So data collection, we had fairly large data set where we collected pre-study survey. It was done on hard copy, and then I created Survey Monkey post-study survey where they were asked to answer some questions after the study is finished, and then time logs, things saying how long it took them to finish the study, and then the actual results, and then action logs, which um, just tells us like what actually requirements they clicked on. It records all the mouse clicks. It tells us how many times they restarted or stopped the project and came back again, and how long they stayed on the project. So threats to validity. So our internal validities, we had human error while performing experiment. We had tracing tool, hypothesis casing. We had personal bias in constructing the intercept matrix. Our construct validity was fairly low since we were using or comparing only measures that are commonly used in requirement tracing studies. Our external validity was experimental dataset itself, since it was developed by the upper division computer science students, where it may not generalize same way to the industry people with experience. So conclusion validity was we have statistical analysis, and reliability validity was that it's fairly low as well, since this study is defined easily, and you can easily repeat the experiment. So total results we collected that we had 20 participants, but only 14 of them actually sent back the results. 5 of them out of that were control version, 9 were the experimental version, and to avoid the unfair comparisons, I went online, generated the random numbers, and chose the 5 experimental version peoples out of that to compare with the control version. So these are the measures that we'll be comparing, and this is the table that shows that what um, um, what percentage of the values or numbers are acceptable, good, or excellent. So for recall, you always want to stay close to 80% or 100%. For precision, we want to stay between 50 to 100%. In lag, we want to stay low as possible, between 0 to 2. So this is the scatter graph of percent precision versus recall. So ideal number would have been close to 50 to 100%, and recall 80 to 100%. But in this category, we received mixed results, and we received better recall at almost 80 to 100% from the experimental tool, and we got little bit better precision at almost 0.82 to um, 0.35%. I mean 35% to 82%. Then we compare the if measure, where since the tool wasn't, one person did not do the both of the versions, so we couldn't really compare the actual results of the comparison, but we could compare how well people did with the F measures. So these F2 measures are they were pretty better on the experimental tool than the control tool. As you can see, for user 2, 4, they had higher F2 measure than the control. So lag comparison, lower the better. So as you can see, almost every user were either close to 2 or they were 0 to 2 lag. So clearly experimental tool performed in lag very well. So if to measure, this also brings us back to our one of our research question, where does the time spent to perform the study improve the precision recall? As you can see that participants spend anywhere from 35 minutes being the lowest to the 120 minutes to the highest time on the experiment. And as the graph shows, that the people who spend 120 minutes had better F2 measures results, and also the experimental tool had better results. So just to compare the precision, um, the both tools pretty much perform poorly on the precision part, but in the experimental 2 and 4 perform better in the on the experimental side. Recall, it was a tie. They almost had very close to 80 to 100% recall in both versions of the tool, and but on the control version, one user almost dropped the recall to down to 10%. So I guess in this scenario, experimental tool, they all of them kind of did fairly well. Could be just the user base. So like I already mentioned, we collected the post-study surveys where they were asked questions like what strategies used to complete the task, do they have any comments for the traceability tool, and some general question comments. So this some of the questions I collected were really interesting, where I asked how confident were your decision making lower and requirements as link or not, and 33% said that they were 90% confident, but clearly 67% answered that they were 80% confident. So majority of our population were only 80% confident in making decisions. Then this was like really mixed results, where we asked them how confident were you that you had found all the links between low level requirement and high level. Clearly almost majority people were only 70% confident about this, and only 15% were 90% confident. So we definitely keep those results in mind for future. So another qualitative analysis, where we want the future developer for the retro experiment to keep in mind that to include these in their, I guess, training or instruction how to use the tool. So these are the methods people found useful in making completing the task. They went through the each high level document and marked low level based on the description, the keyword searches, the wait option, and the switch between the tabs on the retro.net. So we asked them if they had any comments for the tool, and most of them people mentioned that tool was really easy to use. easy to use and follow. The prompt message helped some of them, but some of them found that it was annoying because it was prompting them while they were trying to change the link, previous link decision. So this is the related work as already mentioned. First paper, we kind of follow that to replicate the human study on some modified level. The second and third paper, we took our motivation from it, where they mentioned about the first intuition of the link design is accurate, and then second was like if they take too long, then the threshold value to do the tracing on the requirement, then they would most likely make mistake. Conclusions and future work. So our study definitely confirms that we need to study these interactions between the human analysts and the TMs. Then we definitely want to improve the vetting process by assisting human analysts to make better link decisions, and to the users to work on the coming back to research questions. Do the user work on experimental version perform better than control? Well, the answer is kind of yes and no, because we found that experimental tool perform better in recall if two measures lag, but both of the tools did not perform well in precision. So does the amount of time spent enhances the improvement, um, improve the precision recall? Well, the participant who spent on average of 120 minutes had better results, and all participants took between almost 80 to 120 minutes on average, and our experiment will perform very well regarding lag in that case. Future work, well, we need to recruit more human analysts to come to the better conclusion about the tools, and we plan to take our study and perform our experimental in California Polytechnical State University and Youngstown State University in near future, and we plan to use other data sets in the experiment. Maybe people would have better understanding for those. Um, I definitely want to add a limitation with Retro.net only working on Windows OS. So definitely would want to implement web application of Retro.net where obviously it won't be limited to the particular OS and everybody can participate in one of those experiments. And one thing I found that it is time consuming process, and especially if the data set gets larger. And so we definitely need to improve the auto-generated candidate matrix accuracy to start with, and implement maybe possible data mining techniques or deep learning methods. And then I'll do the demo of our experiment, and the little acknowledgement is that first of all, I would like to thank Dr. Hayes for her great help and guidance throughout the project, and always being available to me for all the questions, and always being really patient with me in answering the questions. And second, I would like to thank all my committee members for taking their time for my defense out of their busy schedules. And lastly, I want to thank all the participants in the study, all the students who participated in the study, and previous Retro.net developers and supporters such as NASA and UNICEF grants who funded this development, and then researchers at Cali Poly for providing us the datasets. Thank you so much for your time, and I'll take any questions that you have.